So you see that group of problems there, 11 to 21 odd? Yes, maybe?
On this page?
Yes. Is that right there? What is it?
479.
479 in your book? Yeah. Because again, is that the only book here?
Almost half mine. I never use it in class. I can leave it. No.
So yeah, I think 479. Problems 11 to 21. They have just shading in areas on a Venn diagram. Is that right? So like, what's number 11 say? Somebody have that?
Like it says A and then the upside down one. A, B.
Okay, so you have A.
Sorry.
No. Actually, good.
With B, and that's in parentheses.
Okay.
And then the upside down U thing. Yeah, with a Z.
Good. Now, in fact, I normally I like to actually have you guys with your books more often, but we haven't been doing it that way, and I recognize that. Because just actually saying it sometimes is trickier than you might think, right? There's actually explaining some of this stuff or dialoguing. So, of course, the way I would read this would be A intersect B, okay? And then once we get that, because we're going to do a little PEMDAS essentially, then intersect with C, right? And isn't the picture 3 circles? Mm-hmm. Yeah, okay, so let me get those. And are these circles in a box?
Yes.
Okay. So what's the box have? What does he say?
U.
Yes, U is the box, not to be confused with, well, those are the other ones anyways, okay. So what they wanted us to do is just to graph this. Okay? Do you guys know how to do that? I'll take that as a no. So we want the intersection of A and B, right? So let me call this A, B, C. And you can see that A and B overlap right here, right? Okay with that? So now we've got this part. Now what we want to have is the intersection of that part with C. So here's C. This is where I need one more color pen. Unfortunate. So now here's C, but it intersects. So right here is the area we're really talking about. Is that okay? Okay. Right below it is, see that was 11. What's 13 maybe? B, and you said what? Union with C prime. Okay. So let me erase this little piece and then... okay, I'll just erase the whole thing. Okay. Actually, let's start off with this. What is C naught? Not C, C prime?
A and B, but not C. No, it's university. It's everything.
Yeah, it's everything but the circle C, okay? So if I were just trying to work on this part right here, it would be everything out here. Okay? So we have this part right here. And then B, we want to know, so here's B. We're going to combine this with B, right? And you see most of B is already included, so that doesn't really change there, right? So when I do a union, it's going to get bigger. So what part, I'm already doing everything in blue here. Where would it get bigger? Because we're combining it, doing a union with B.
Section where it overlaps with B.
So now this part does overlap, right? But we're saying that's actually already counted. It's already part of C naught, right? So we're going to add to that B that's not. So then it would be just this part of B, right? What should I do here? It's that part of B. We'll add to it as well, okay? Is that all right? Okay, so now we've done what's inside the parentheses and everything that's not C, and then we added B to that, which only added a little bit. This part was already covered, right? Okay. And now we're going to go intersect. So where does everything in blue intersect with A?
Little piece.
So it's going to be for sure this part right here, right? But it would also be then this part here to there. Okay, so it'd be that and that. So we took all of this, treated as one thing, which was everything out here and this, and we said, where does that stuff overlap the A? And it overlaps the A out here and that funny little piece. How's that? Okay, I sense we should do a few more. Okay. Now what I need you to do is tell me when these are getting boring because, well, let me rephrase that. That may have already happened. What I need you to do is tell me when they're getting too easy, okay? So that we know not to keep doing them. So we just did 13. Is there another one you'd like to do? Should we just go down 15? Or do you feel like 15 is easy enough? Help me out. I'm sorry. Again, I didn't ask you to bring your books. You're kind of at a disadvantage.
Do we have to do the odd ones?
No, you can pick an even one.
Did we do 20?
Sure, let's do 20. Okay?
That's A prime, union, with parentheses, B prime, intersection, the C prime also, in parentheses.
Okay, like that. Okay, here we go. So again, we're going to start inside the parentheses. And I'm going to start with C prime, but it could be B prime. It doesn't matter at that point, right? So not C. We already did that one. So it's everything out. Here, let me label these again. A, B, C. So boy, this is a bummer of a day not to have a green pen with me or a red pen or something. I bet. No green, but we'll take red. Okay, so there we go. So there's our C prime. So now let's do B prime is going to be everything here. Okay with that? So now this is the intersection, so every place it overlaps, right? So let's see, where do I have, so every place I have blue and red hatching. So it would be, so everything out here, right? See, it's everything over there. And let's see, but not in here, right? Doesn't include all this. So I'm going to go right along here, and but does not include everything in there. So would you agree everything outside of those is what we're talking about? Okay, so we've got that. It's kind of a mess. So we've got everything outside of this kind of figure 8 shape. And now I'm going to combine it with, right, that's union, with not A. So let's see here. Okay, let me do not A in black. So there's not A. How you doing at making sense out of that, huh? Okay, not A is these black lines coming out from the A. Okay? So now what I want to do is combine. So this, we're not doing overlap here. We're actually combining, right? So I want everything that's here and this, right? So first thing is, remember now, I drew this funny H shape. We were saying everything outside of that, right? So we already have that area. So all we have to do is see what does A contribute, or this not A contribute to what we already have, right? So we were excluding this, but now what we can do is every place we have this black cross hatching, we're going to add that in now, right? So this here is all going to get added in. So let me do this. The part that doesn't count would be, I'll erase. So it's either got black hatching or it has red and blue hatching, right? Out here. So this is the only part that doesn't count. Everything else is part of this. What do you think, Anna?
So everything but that little would be like shaded?
Would be what they're talking about. That's right.
Everything that's not shaded.
Right. This is the only part we are not talking about. Okay. Well, some of you guys have some pretty nice drawings out there, actually. Okay. Should we talk about this one more, or just try a few more until it starts to feel better? Okay, what's another one?
Do 19.
Okay. And what's that one say?
That's parentheses A, union B prime, in parentheses, and then intersects with C.
Like that. Okay. And looks like I should have tried to steal a black pen while I was at it. Okay, so I think we'll start with B prime. Is that good? So we're saying everything that's not B. And I'll do this here in red, since red's working right now. Okay, so we want everything that's outside of Okay, so that's the first thing we're talking about, right? And then we want to combine that, so union with A. Let's see. So we're going to take everything out here in red, and we're going to add in all of A, right? Now this part here, out here, is already included, right? So the only thing we're really gaining is this piece of red over of A over here, right? So I guess, how should I do that? Squiggly line. So I'm going to do A's. Maybe there'll be some logic to my madness here. So there we go. There is A, but then it's everything in red then is what we're talking about, right? So it's the red out here And so what we've done is we've added it in this little piece here. That's the only thing we gain by doing that. Now we're going to find this whole thing we've got marked up there. Where does it intersect C? So here's C. And so now you can see it intersects right in. Yeah, that's got to stay inside of C here. So there's where C intersects this other red stuff. There, along there, along like that.
So when there's something intersecting, it's the entire thing. That's where I was confused. I was trying to do the homework, and I thought like just that little piece where, because intersecting means like where both of them is included. Correct?
Yes.
Like if we're going back to like the other examples. But in this case, like I would have thought that just the overlapping part means what's intersecting.
Yeah, I do.
But the entire
Okay.
thing is intersecting.
Well-
So that's where I'm confused.
Now,
Does it intersect with?
what you said is true, so I think we need to iron this out here. It shouldn't be
Okay.
inconsistent.
So does the rest of C intersect because it intersects with B prime?
So we are treating this here as one group. Okay? The first thing, when we did the union of those, we're just treating them. So everything that's red, whether it was red because of the A part or red because of the B not part. Okay?
Okay.
So we're saying, where does C overlap anything in red? Okay? And so, of course, here is C. And so any place there's red is what I want. And, of course, it has to be inside of C. So now, is that consistent, Anna?
Yeah, that makes more sense to me.
Okay. And you're okay with that too?
Yes.
No? So, what do you think? You guys want to do a couple more of these, or do you want to try to move on? Okay. Do you want to pick out one, Mariah? So we just did we've done 19 and 20.
Let's do number 15.
You want to do 15? Okay. I'll just keep making my box and circles smaller so I don't use as much ink. Okay, what's 15?
They're all prime and they all intersect. So it's A prime, intersect
In-
B prime, parentheses, and then intersect C prime.
Okay. So anything, first I'll start off with outside of A. I'll do that with blue. And okay, then outside of B, now is when I need my green pen. So outside of C, so what we want now, the area that we're after then would be everything that has red, blue, and black shading, right? You have to have all three. So let me see if I can kind of outline that. So inside of the circles, none of the insides of the circles have all three, right? Okay. So, but you can see out here I have all three. So I'm talking about above the line. So above the line. Let's see. I should, yeah, actually, here's some red. So there's red there. So this is telling us everywhere outside of those circles, right? Where I could erase all the stuff inside. None of the stuff inside has all three colors. So all of this outside is what we're talking about there. Is that good? Can I erase it? Mariah, did you have one more you wanted to do here? Nope. You're good? So we're going to move on now? Okay. Let's see. Someone, I'm going to have you read 32 to me. Actually, no, let me get my circles back up here. Okay, so this is problem 32 in your book. And it's kind of long, but can somebody just kind of read that to me?
We have n parentheses a equals 13.
Okay.
N parentheses a intersect C.
Oh, this, just a sec. So I need to, this is intersect all of them? Like this, oops. Like that.
Yes.
Okay?
And then equals 4, comma,
Okay?
and parentheses A intersect C equals 6, comma,
Okay?
and parentheses A intersect B prime
B prime, okay?
equals 6, comma,
Okay?
and parentheses B intersect C equals 6, comma.
Were one of these prime? I can't remember.
So it should be A intersect B prime, and you have that.
Okay.
And then it's
B and C?
B and C.
Okay.
And then the next one is M parentheses B intersect C prime equals 11.
Okay?
M intersect B union C equals 22.
Okay?
And then M parentheses A prime intersect B prime intersect C prime equals 5.
Okay, so there's the problem, right? And let me tell you the order I think. I would not start here and go to here, okay? What you want to do is pick and choose which ones are easiest and leave the harder ones, okay? And so the ones I like to grab first would be, for example, here it just tells me what's inside of A, what's inside of B, what's inside of C. And everyone, this says the number of things inside of that set. Remember that? Okay, so it's saying set A has 13 things in it. Okay, so this is a good one to start with. And here's my own notation. I like to write outside of the circle, I'll put a 13. Okay? And the reason I don't write it inside the circle is because this 13 is going to be divided up some here, some here, some here, some here, right? So if I were to put it in here, it would imply that this region here is 13. Okay? So when it tells you the number inside of A, B, or C, I like to put it outside of the circle. It's not something the book does, but that's how I keep track of it. Okay? So we've got this one. And let's see. The next one I like to find, if at all possible, is that. Okay? And so where does circle A, circle B, circle C, they all overlap right there, right? Which is what they have listed right there for us. Okay? So let's put that one in. So this is going to be 4 right there. And a lot of times this isn't going to be number 2 in your list. It's going to be like buried down here somewhere. So I would go find that one, okay? And then let's see, do they tell us if you can get that one? The next thing you want to look for is there something about the overlap of B and C, the overlap of or intersection of A and C or A and B. Okay? And so let's see. Here we have the intersection of A and C, right? Which would be this area right there, right? Okay? Now, it says 6. Let me just put a funny little... There's 6, but it's actually in this whole area here, right? So then what would be right there? 2. Okay? And so we've got that one now. Let's see here. Oh, here we have a nice one. Intersection of B and C, right? So we're saying the intersection of B and C is also 6. So this thing here. Yep, so we got a 2 here as well. Good. So we've got that one out of the way. And let's see. This one's actually kind of a helpful one too. This is not in A, not in B, not in C, right? And we just graphed that a moment ago. Where is not inside of any of the circles? Then it's everything outside the circle, right? So then we can just go right to this and say this is 5 out here, right? So that's the universal set of courses in the box. Okay, so we've got that one. Okay, now it leaves us then these 3 to work through, a little slower maybe, but if you were to start with these, you can't really get anywhere. So you want to, again, go through and pick the easy ones. So now this one says if I combine B and C, I get 22, right? The union of them. So we're saying this whole circle and that whole circle is 22. It looks like we don't quite have enough. Let's see. Yeah. So it looks like we have 3 spaces in there, so we don't have to come back to that one yet, right? So we need to come back. Let's see if we can get this one here. So this says intersection of B and not C. So this was saying everything outside of, so everything out here intersects B. So that would be this region right here, right? And so, let's see, we have, there's going to be 11 there. So the catch is it's divided out between here and here, so we can't really make a decision yet on that, right? Okay. And let's see, hopefully one of these will break through for us. So this says A intersect not B. So let's think here. This one says if I'm outside of B, intersecting A, it would be this region right here, isn't it, right? Oh, good. So we can get this one. So there's got to be then 6 in here, right? I'm outside of B, but I'm still inside of A. So now that's really helpful, actually. So we just got that one.
So that leaves 1 with the.
Yes. Now that we know that one, we can get this one, right? Did I go too fast on that?
Why wouldn't it be for the last one, the A intersects
B not?
prime? Yeah. Why wouldn't it be 4? Because that section, the 2.
Oh, yes. Good. Everyone get Amy's comment?
Yeah.
Okay. Yeah, we had 2 in there and I messed, so you're right. So what we knew is that actually that this area here was the 6. So then you're right, this would make this 4. Good. Thank you. Okay, so now with that in mind, let's try to go back and get these 2 here. So it says, again, this is intersection of B and not C. Oh, actually, sorry, one more thing. If I know these 3, and I know that's 13, right? Then how many are right here? 3. Is everyone okay with that? How are we getting that? Yes, okay.
8 is the rest of B.
What is that?
Would 8 be the rest of B?
So, well, yeah, too bad we don't know that, but...
Well, don't we though? Because it's everything.
Well, we can, we should be able to get one of these now, right?
Yeah.
Yeah, so we know that, let's see, we know that 22 is divided between those, but we can get, this here was B, but not C. So that was this region here is 11. So you're right. If this part here is 11, then this must be 8, right? Okay. And now we can finally, so we just got that one. Now we can use this one here. There are 22 inside of B and C, right? And I can account for 10, 19 of those, right? So there must be 3 in here. How's that? Okay. Can I go ahead and erase it? And should we do one more of these guys, or you guys think you've seen enough?
Let's do one more.
Do one more? Okay. Then I think we should try to do, let's see, what's question 36 and 34 say? But I really wanted to do 45.
36 and 34.
Yeah, what are those questions anyways?
It wants you to show that the statement is true by drawing Venn diagrams and shading the regions representing
Oh.
on each side of the equal sign.
Okay.
And then 34 is parentheses A intersect B parentheses prime equal to A prime union B prime.
Okay. So we'll come back to that one if we have time. I think more important would be then, thanks for reminding me. Let's try to do 45 then, okay? It's going to be another one of these circle guys. So, problem 45. Can someone read the information they gave us there?
You want 22 or tall?
Yes, that's right. Okay. 22 or tall.
25 had green peas. 39 had smooth peas.
30 how many?
39.
Okay, smooth.
9 were tall and had green peas.
Tall and green. Okay.
20 had green peas and smooth peas. 6 had all 3 characteristics. 4 had none of the characteristics.
Okay. Is that it?
And then just find the number of plants that were tall and had 40 peas.
Okay. So instead of answering the questions exactly that are in the book, we're just going to try to answer everything, all right? So I'm going to call this one tall, green, and smooth. Do you recognize where this comes from historically, by the way? Anybody?
So the hybrid from biology.
Yes, right. But I mean, who came up with this first? So yes, you are correct. Who was the first guy to do this? No idea? So he was a priest that was out there planting peas in his backyard. Mendel. You guys heard of Mendel?
Yeah.
Yeah. Yeah, I think he spent more time planting peas than doing priest things, but and the bummer is he didn't get any credit for this. Now we think he's the greatest guy at the beginning of genetics, right? It was right here. But the poor guy during his life didn't get any credit for all of his work with. I mean, he was so meticulous at this, it was amazing. Had he picked a different variety of plants, it wouldn't have worked. That's the good. There was a stroke of luck there, though. Okay, so let's just try to fill it all in, okay? So 22 are tall. So I'm going to stick that out here because it is outside. 25 are green. Okay. 39 are smooth. So it's kind of nice they're giving us these numbers. Tall and green. So let's see here. So we're saying in this area here, tall and green is 9. Green and smooth. So this overlapping area is 20. Let's see. Oh, there we go. 6 pops into the middle. That's one I normally start with, but and 4 had none of these characteristics, which makes you wonder if they're not green. Well, I guess they could be brown, right? If they're not tall, they could be short. They could be wrinkly. I guess those are. So outside of the short, wrinkly brown peas. Okay. So, but now we need to fill in a lot more, right? We need to fill in all these little spaces here. So let's see what we can do. Let's see. And just want to make sure I do have all the information here, right? So we jump into this. Let's see here. I almost feel like I'm missing something, but maybe not. Well, okay. So what would this be here? We know that this is 20. We can tell this, right? What would be this spot right here? Good. 14. And we know this is 9, so then this must be, yeah. Good. And what else can we do? Oh, if I know this, I can figure out that, right? What is that? Everyone happy there? Okay, so we're doing really good over in this part of the region. Now we've got these 3 blanks, and it seems like we just don't have...
There's 50 plants total.
Oh, okay, that's helpful. So we're saying the universal set is 50. Good, we may need that pretty soon. All right. So if you run into one of these situations, here's what you need to do. I would recommend calling this one X right there, okay? You could pick one of the other spots as X, but in general, that's a hair easier. So now if that is X, then if I know all 3 of these, in a sense, and I know this 39 total, how many must be in here? If I take 39, subtract 20, I'm at 19, right? 19 minus X, okay? Which isn't as satisfying as a real number, but it's still something we can hang on to, right? And if I come up here, there's 9 there. So 22 minus 9, so I'd have 13 minus X, correct? Okay. Now, notice that we have a number now in every, or a variable, every different region. Is that right? And in fact, what we know then is that if I were to add these guys all up, so 13 minus X plus 3 plus 2 plus 6 plus 14 plus X minus 9 plus, let's see, what do I have? 4. Is that everybody? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there we go. You agree? And if I add these all up, what do they have to equal? 50. That's right. So let's do it. So if I do the x's, it looks like I get negative x, right? Okay. And, you guys want to help me with this? What's this come up to be? 60 something that I missed, then I lost track. 61, okay. So what we have then is that 61 minus x must be equal to 50, because we know they have that, right? So now we can do some nice algebra. Negative x equals negative 11, or better yet, x is equal to 11. So now I can come back over here and say, this is 11, which 19 minus 11 gives me 8. 13 minus 11 will give me 2. And now we can answer all the questions. Right? So then the questions in the book will simply say, well, how many are, what do you have now for the overlap between tall and smooth? And you could easily say 17, right? So that's what the questions will be. The hard part is getting all the spaces filled in. Okay, can I erase it all? All right. So there's the Venn diagram stuff. And you're probably like, why in the world do we even mess with this stuff, right? Of course. And if you were to nab me, I'll see, what year was that? Well, it was beginning of my junior year in engineering. I had to take problem stat. And I thought, what a waste of time. I'm going to build stuff that works. I don't want to know the probability of it working. Right? I mean, does it make... So that was the class that was my lowest math grade. I did pass. That's all I put all my attention into electronics and circuits and all that fun stuff. And my stat classes barely made it. And do you know what? The absolute most interesting job I did while working at Boeing, the probability that my brand new box would make the plane crash. I'm totally serious. Every time you would add one little piece to the airplane, there's a number out there. There is. I can look it up for you. What's the probability of any particular airplane crashing on any flight? And we know exactly what that number is. We don't advertise it.
I don't know if I would want to know that number on a plane.
Yeah. So, in fact, probability was huge. I just had no idea. So, like my little box, I could show you a picture of my box sometime. Had about 400 little electronic parts in it. And we had the probability that each one of those parts, I'll just bring some parts in for you on Wednesday. But we had the probability figured out that each part, how often it would fail. Like this little part, it'd be so much easier if I was holding one of the parts, right? The probability would be 1 in every, 7 million hours. And this would be 1 in every 3 million hours. And so you had to take and combine them all together, using the rules of probability. And the net result is when you first did all the math and the answer popped out, you've made the plane unreliable. Too unreliable. So we had to go back and change the design to make it reliable enough. Again, that's the number we don't tell you guys about. But so, ironically.
So good enough makes you think like you need the bare minimum of what you need for it to be successful. After work, you play?
Oh, I sleep well.
Yeah.
I would fly tomorrow and sleep well.
Yeah.
Yeah.
That's all I need to know.
Yeah.
Yeah. And you'll still fly after knowing the probability.
Yep. Actually, the way they phrase it is the probability that a crew member would have to take, there's 3 categories. There's 3 basic categories. And the way they phrase it is something like the crew has to do something that normally wouldn't have to happen very often, like, reach up, turn this off, continue flying kind of thing. Or the probability that a crew will have to do something that's really hard and he may or may not succeed in doing it. It's kind of interesting to think about that. But so I want to start the probability section just a little bit, okay? So, man, the stats has just got tons of words, okay? And so the Venn diagrams and all this, it really is stuff we need to know to be able to do probability. And it's interesting enough, in medicine, for those of you kind of going that direction, you may have, you wouldn't be surprised if a doctor came to some patient and said, well, you have a 1 in 5 chance of not making it through the surgery, right? And then we can complicate it by saying the test that they did on you, though, is 90% accurate. So now you have two pieces of probability you need to try to combine for a patient to understand, should I be doing the surgery or just letting it go, right? So actually it pops up in your field too, for those of you heading in that direction. But anyway, so here's some words. Let's try to get through them. Let's see. Let's see. And there's more, but if we get through these, we'll be doing good. Okay, so first, in my hand, I have a regular die, which, by the way, you'll notice as you're going through the book, they will keep saying the words a fair die or fair dice. So it's not like you could imagine you could somehow put some weight in there so it would always pop up a 1 or a 6, depending what you're... So we're saying these equally likely to get a 5 is a 2. Okay? And this is a fair coin. Where did I find this? This is old. Wow. This is really old. Huh?
How old?
Okay, so not really, really old, but it's 52.
Okay. Huh?
Yeah. Older than most of us. Older than me. By quite a bit, actually. So if I were to shake these two guys, that's an experiment, okay? And we could have, shake and shake and shake. In fact, by shaking one time, that was a trial. But, if we shake a dozen times, that's our experiment, okay? So those are easy words. And of course, an outcome would be, in this case, the outcome was a tail and a 1, okay? Now we want to talk about sample space. So as I start shaking these guys, one thing that will be helpful is to know what are all the possible outcomes I could get. So can you help list them off for me? I'm shaking one penny and one regular die. Tell me one of the outcomes.
One could go heads and then 1d6 and it could be...
Okay, so yes, you're being efficient.
It's like, it could take way too long to let everything individually hunt.
Yes, you're right.
And then same thing for nails.
Okay, and then you're right. We're going to have a tail here, and a 1, and a tail, and a 2, and yes. Okay? So the main thing we want to grab right now, though, is if you add these all up, we have how many? 12, right? And a lot of times that's really the number you're after. So you need to find out how many total ways can things happen, okay? All right, so there we go. That's our sample space. Now, an event or events, what's going to happen is you will be asked the question now, what is the probability of a certain event occurring? An event might be, let's say the event they are most interested in would be a head and an even number. So how many ways can we get a head and an even number? So you'd come over here and you'd say 1, 2, 3, right? So we'd say there's 3 ways to get that particular event. So when we talk about an event, it could be a particular result, one particular outcome, or it might be a kind of more of a category, like in this case. So this actually is 3 possible outcomes would be the event we're looking for. You're okay with that? Okay? And let's see. And we're almost out of time. One more word, one more picture. So mutually exclusive. If I were making a Venn diagram, in fact, this could be my coin, and this could be my die. Okay. So in here, I would of course have heads and tails. Over here, I had 1, 2, 3, 4, 5, 6, but they don't overlap in any way. They're completely independent or mutually exclusive. Okay. And the easiest way for me to explain mutually exclusive is to tell you something that's not mutually exclusive, okay? So I could ask you, what's the probability of getting a red card? Actually, of course, in a deck, we should, in case you don't know, 52 cards, right? You have 13 diamonds, 13 spades. Sorry, it's an ugly one. Starting to rush here. And thank you. And of course you have 1 through 10, Jack, Queen, and King in each of those, right? So just kind of helpful. But if I were to ask you the probability of a red card and maybe a King, those are not mutually exclusive. You see how they overlap, right? Because there are red kings. So that's a later assignment. We will go there for sure. But when we talk about mutually exclusive, which is where we're starting, you don't have to worry about the things overlapping like we will eventually. Okay? So you can definitely do 10.2 and you could start into this one. So this is the Venn diagram one. And then this is the beginning of probability. So I would start a little bit into that. And maybe you'll get into it far enough that we can start with just some questions on it as well. Okay. but I'm not quite, we haven't done any examples here, of course. We've just started to try to talk about the words. Everyone good?
And then all on Thursday. Yeah.
Yes. If you don't find it there, send me an email.